Hello everyone, my name is Shuin Kashi and you're watching AstroIsland. For those of you who are back on the channel, welcome back. And for those of you watching for the first time, don't forget to click that like button, click on that subscribe button so you can get notifications of when I launch new videos that will be very helpful to you and many others in the astronomy and astrophotography community. Now, today we're going to go through the very basics of processing an image. And the image that I choose in particular is the Great Orion Nebula. Why did I choose that particular one? Well, it's mainly because many of us, like myself, live in Bottle 7 or higher, really bright and light polluted skies. And even though we live in those type of skies, many times if you use binoculars or sometimes even a really great phone, you can still view or capture the Great Orion Nebula. And that's what we're going to do today. I've already captured these images, so we're going to go through and walk through the process of processing that image from beginning to end. So without further ado, let's get started, shall we? Right, so we are now on the computer, and what we're about to do is to organize everything that we've done when we capture that image on that particular night. In this instance, as I mentioned, we captured M42 or Messier 42, also known as the Great Orion Nebula. And the lights, which are the images captured of the actual object, goes into a particular folder called lights. In my case, I'd have captured Orion for 2 nights, but because this is a very basic tutorial, we're going to just stick to using or processing the image for 1 night only. All of those images of Orion are now in a folder called lights, and I would have captured 54 of them at 180 seconds each, or 3 minutes each exposures. Next up, we have what we call darks. So after the lights, I usually capture darks. And in this instance, because I have a cooled camera, the ASI 294 MC Pro camera, it's a cooled camera, I brought the temperature down to minus 10 degrees. And according to the record, it shows that in my instance, minus 10 assists in removing a lot of the noise. All right, so I would have captured 50 of these at again 180 seconds each. Now, something to note of critical importance. All of the images being captured on a particular night must be at the same exposures, or usually should be at the same exposures if you want to get the best quality images. So my camera, I had the shutter exposure remaining at 180 seconds each, and it's equally important to ensure that when you're doing the dark frames, you capture them at 180 seconds each as well. And to capture the darks, you basically now put the dust cap or a dark piece of cloth or something really dark to cover the camera lens and the telescope, with more or less, for lack of a better word, capturing nothing for 180 seconds each. And most people capture 25 or 30. I like to go a little above and beyond, so I capture 50 for most of my images. And of course, it's recommended to have the images or the dark frames being captured in a dark room as well. You don't want any stray light coming in, because now the images or that dark images are going to be, a little bit skewed. It's not going to be equally dark for each of them. Right, so up next, we're going to do capturing flat frames. And what flat frames do, it removes anything such as dust that may appear on the telescope or the camera. And also it removes what is called vignetting. So usually how flat frames are done is you have a white piece of t-shirt and you place it on the top end of the diameter of your telescope, or in some instances, if you're using a DSLR camera, the top of the camera lens. You cover it, make sure it's nice and tight, and then you place an evenly lit source on top of that white t-shirt. Some people may use an iPhone or a laptop, but it's ideal usually to get like a flat panel, and I'll put in the description down below usually some of the flat panels that people use, and I'm going to also put the one that I use. And now you begin capturing your line frames, sorry, your flat frames, and that's usually about 3 to 5 seconds. So if we go into the flat frames, I would have captured the flat frames 3 seconds in my instance, and I would have captured 50 of them. So usually in my processing for the darks and the flats and any of the calibration frames, I usually use 50 because I capture quite a lot of images. But anything below 25 images of the lights, I usually capture maybe 25 to 30 calibration frames. Right, and next up, what we're going to do is show you how to do the dark flats. So what that basically is, now you remove the white t-shirt, you place the dust cap or the lens cap back onto the telescope, and now you begin capturing at the same exposure length. In, as I mentioned, I used 3 seconds. So now you're going to do the same for whatever number of seconds for your device and capture it for same thing about 25 or 30 or 50 of those for, between 3 to 5 seconds, and you're good to go. So the flats, the darks, and the dark flats are what we call calibration frames. Now, let me know if you want me to create another video where that is concerned, so I show you how to capture each of them. So that way you can be 100% sure learning how you go about doing calibration frames. So now that we have all of our images organized into one folder and we have our calibration frames into their respective folders, it's now time to use a program that's going to stack all of them together and then process that image thereafter. The program that I'll be using today is called Pixinsight. And in my previous video, I'd have shown you how to install and configure Pixinsight. So if during that process you have any issues with the installation, please refer to that program and drop some comments down below if you need any help. So we're going to launch Pixinsight. Right, I've already have it launched. And usually one of the first things that I do is create what is called a cosmetic correction script or cosmetic correction process. So we go to process, all processes, and where are you? Cosmetic correction. There we go. So we click on it and we click on use auto detect. Now I would have seen this on Adam Block's video in terms of using cosmetic correction before you begin stacking your images, and I'm going to show you why. Because again, remember we spoke about the dark frames and some of the other calibration frames. It creates sometimes hot pixels and cold pixels, and what this does, it does a correction of some of these issues that may occur when capturing images and those hot pixels begin to appear. So we usually just select use auto detect, and then you can just drag it using this triangle onto the desktop or the workspace that they call it in Pixinsight. And that's it. You can rename it if you want. They call it set icon identifier, and you can name it whatever you would like. Now in my instance, I've already created a few shortcuts. So let me just load those for you. Alright, so these are basically all of the different processes or most of the various processes that I'll be using. So as you can see, cosmetic correction is already here with the same settings that I showed you before. So now what we do, we go to script, batch processing, weighted batch preprocessing. So the first step after you've captured the images, you want to begin stacking them, which is basically taking what it be. You have 25 lights, 100 lights, 1,000 lights. You want to now stack all of these now to begin creating one image with lots of detail that we're going to what you call stretch afterwards and bring out that nice fine detail that you've worked so hard to collect. Right, so now that we have weighted batch preprocessing script launch, it's time to now add those lights and add all of those calibration frames into their respective tabs. So of course, we click on lights. And now we need to find that folder where the lights are contained. So in my instance, I go right here to lights, select session night 1, select all of the images that I've captured. You can just basically press Ctrl and A on your keyboard if you're using Windows, and you click open. So now all of the light images are in the lights tab. Then you go over to flats and you just basically do the same thing. So if you go over to the flats tab, we can now see all of the flats are in their respective, lined up right here in the respective tab. Then we go to darks and do the same thing. Right, so then now the darks are in their respective tab. Now, here's one thing a lot of people make mistake. Because some people call it dark flats and then other people call it flat darks, they have a tendency to put the dark flats in the flats tab, but it's actually a dark. If you know, it's called a dark. Even though we call it dark flats or flat darks, it's actually a dark, because remember, you're taking the what you call it, the white t-shirt off, and you're putting a cover over the telescope and taking dark images. So that's why you must ensure that it's in the darks tab. So you go back to darks again, and this time we add the dark flats inside of there. See? And there you go. So now we have the darks above and the dark flats lower down below. Next up, if you're using a DSLR camera, then you would have added what is called biases or bias frames. But because we're using a cooled camera, we insert those dark flats inside of here, inside of the darks. And usually, if I remember correctly, because it's been a little while since I've used a DSLR camera, I believe the bias frames are much shorter than those 3 to 5 seconds. Usually I think maybe 1 second or even less. So usually if you're using a DSLR camera, you do need to take dark flats, but instead you take what are called bias frames, and they go inside of this tab. So now we have all of the calibration frames and the lights in their respective tabs. It's time to move on. Usually we leave everything at the default settings. Let me just show you how everything looks. All right, so you can look at it very carefully when you're setting up weighted batch preprocessing to ensure that everything matches. Some people, they switch this from PSF signal weight to PSF scale SNR. And if I recall correctly, I think like if you have really clean images, then you can go to PSF scale SNR. But if you have 1 or 2 images that may have been, you know, a little bit inconsistent, you can use the PSF signal weight, and I will just measure all of the quality of the images, and then keep the really good ones, and then reject the not so good or the bad ones, and remove those from the final stack. Right? And once you have everything lined up correctly, you'll see all of these check marks. So you see, everything looks good on all ends. Now remember I spoke earlier about the dark frames and the light frames being of equal exposure lengths. Now let's say, for example, if the dark frames were maybe 60 seconds and the lights were 180, you'd have gotten an error here saying that they don't match up. Because as I mentioned earlier, the light frames and the dark frames must be of equal exposure lengths. So that's why everything looks really good here right now. Usually everything else here, it's a default. And remember, we created that, let me just shift this aside, that cosmetic correction. We come here now where it says cosmetic correction, and we select it. So in our lights, it's going to help remove any of those, as I mentioned, those bad pixels that may have gotten that came up on your images. And if you have multiple nights, you just basically click apply to all light frames, and you can still click it even if it's just one night. That's quite all right. If you're using a monochrome camera, this needs to be disabled. But in my instance, I'm using a cool camera, the ASI 294 MC Pro, which is a one-shot color camera. So with one-shot color cameras, and even with DSLRs, if I remember correctly, this must be on. This must be enabled. And where it says mosaic pattern, you can leave it on auto, but just to be sure to avoid any issues, I usually just select RGB, which of course it's a color image, so it's going to be RGB or RGGB. And then again, we click apply to all light frames. See, so a message is going to pop up. This operation will apply to the same CFA settings of the selected group to all light groups of the session. Do you want to proceed? Definitely. Now, if you have, as I mentioned before, multiple nights, you can do what is called grouping keywords. So now everything will be sectionized or categorized by each night, because what you don't want to have all of the nights jumble up into one particular stack. So what's going to happen is if you have multiple nights, they'll come down in their own various sections for each of their various calibration frames as well. Everything is going to match up equally, which again, as I mentioned, is going to be, I'm going to show that to you in another video. So because I don't have any multiple nights, I can just remove this. Configure WBP for maximum speed or quality. We select this, and then I just usually, I want the best, so I click apply. Now, if your PC is, not that, as I always say, if your PC doesn't have that much horsepower, then you can just select maybe faster with lower quality or faster with good quality. But I have a pretty robust PC, so I use maximum quality and click apply. Everything else, we leave it at its default. And of course, you must know where the output is. So we come here and we select wherever we want it to go. I can just, where is it? I can just create it inside of here, Pixinsight results. And I'm going to create another folder called M42. Right, and there we go. Select it, select that folder, and that's where the final stack is going to go. We go across now to post calibration. It's going to give you more or less the final result, how everything is going to look. Now, usually, I always select, and again, it's always recommended to do what is called drizzling. So I click on here and select a scale of 1. Now, if your image is undersampled, and let me know if you want me to explain what undersampling is in detail in another video, but if your image is undersampled, you may need to increase the scale. So I have another telescope that uses the same ASI 294 MC Pro, and it's undersampled, so I click on 2. But just quickly, in a nutshell, undersampling is basically where when you're capturing the images, it's a little bit blocky, or the pixels are a little bit spaced out when being captured by the camera. So your final stack, especially when you look at the stars, they're going to look a little bit blocky. And what drizzling does, it sort of brings everything back together to make it nice square pixels. Now, what is always recommended in order for drizzle to work, you must do something called dithering of your images when you're actually capturing them during that night. And what dithering does, it's basically your telescope or the software, whether you're using Mina or the ASI, it's telling your camera and it's telling your telescope to just move just a little bit, just by a few pixels. So that way everything will stay nice and organized, and that way you don't get what is called banding, which is just a whole bunch of lines that sometimes appears on your final image. So in order to avoid that, you do what is called dithering, which basically moves the pixels around just by just by a little bit, or moves the telescope around just by a little bit, so the pixels can be much more organized. And in that way, when you drizzle, everything will look really nice with much more details. So whether your image is undersampled or not, I say always dither. And if your image is undersampled, dither. And then when you come into Pixinsight or any of your processing software, you can now select your drizzling configuration, maybe by 2 or more, depending. All right, but if your image is not it's not undersampled, then you can just leave it as one, and I believe it should be all right. So with this particular setup that I had, which was a Celestron 130 SLT and the ASI 294 MC Pro, they were sampled pretty well. So in this instance, I just drizzle under 1, or the scale of 1. And that's it. You click on the pipeline and it's just going to give you the step that's going to happen after you click on run. So just to quickly recap, we've launched the weighted batch preprocessing. We've installed, or we've inserted our lights into their particular tab. Same thing for flats and darks, as well as the dark flats. Remember, dark flats and darks go into the same tab. We've left everything else basically at default. Calibration frames, everything looks good. We go to apply the light frames. We select cosmetic correction, apply to light frames. Color cameras, use CFA and monochrome, we disable. I usually select RGB. And then if you have multiple nights, you group by keywords, which I'll show you in another video. And then we output where we want the final stack to go. And that's basically it. So we click on run. Another menu is going to come up telling you how everything is going to look. Once you have no errors, then you've done a really good job. And after that, we click continue. And there you have it, folks. That is part 1 to the tutorial of capturing and creating calibration frames and just stacking for one particular night. So as mentioned, I'm going to do a part 2 where I'm going to do the same steps, but this time showing you how to stack images where there are multiple nights. So as always, don't forget to click that like button. It really helps the channel. It helps to spread the word to many others who are looking for help out there on how to process images, learn about astronomy and astrophotography. Also, don't forget to click on that subscribe button so that you can get notifications when I launch new videos. As always, I always close off by saying, it's not the size of a telescope that counts, it's how you use it. Thank you very much. See you in the next video. Bye for now.